Okay, let us start the lecture. We can't, wait for others, right? We can't wait for others because there's no guarantee that, they will come to the class. Those who want the class and maintain attendance to get marks can attend even later, right? Otherwise, I continue, right? Okay. Let me introduce lesson number 4.
Recording in progress.
Okay. Let me introduce lesson number 4. Representing the real world in the computer. Right? A different computer.
Recording stopped. Recording in progress.
Representing the real world in the computer. So these are the contents that I'm going to discuss. And our learning outcomes I have written here. You can read them visually. Right. First, we have to understand what is real world. Basically, real world is the world that we are living. We don't have 2, 3 worlds, right? So this is the world that we are living. So what is in particular with this real world, right? It contains which are known as things. In different eras, people represent these by different words, right? Sometimes in physics, you call them matter, right? But today the things have been changed. We call them things. The common name is things. Now we will see in our real world there are living things and non-living things, right? That is the first category that we can see. Living things and non-living things. I don't think I should explain what are living things, right? All the living beings, including plants, and there are some small creatures, right? Microorganisms, all are living things, right? Then others are the physical objects, physical things that we get in the real world. Physical things include many other things, right? Say in our real world system, it is a system basically. In our real world system, there are planets. If you go to the atomic level, we get atoms, electrons, right? So in between, we find billions of things, physical things. Certain things are visible to your naked eye, right? Certain things are invisible to the naked eye, such as electrons, very small things. But we are able to see it through electron microscopes or using the technology, right? Most of the things that in the living world are physical objects, physical things which are tangible. Tangible means you can touch them. You can touch them. There are things which are virtual. Virtual means intangible. For example, take a color, rainbow color, or the rainbow, right? They are phenomena. They are intangible things, but we use them. We see them, right? They are intangible things, right? So that is why we say our world, the real world, is highly complex, right? Nobody is able to tell when it started, when it ends. From time to time, people bring different theories, right? Different theories to explain what is real world. This was created, or some people say it's not created, but it when the things become right. My students don't switch on your. So when you disturb, I'm not I don't care, right? I will shortcut all these things. You will be you are the ones who will suffer. When I say don't do it. Every time I have to tell, just like for the kids, Montessori. Okay, now you all know these things. Now I will go to the next page, right? I will go to the next page, no problem. So you will continue the lecture by interrupting me. So I am not worried, because it's coming from you, because you don't want the lecture, you come and interrupt that. And this is what I see. But you will, in the final examination, right, you will see it, right? You get the result. You will get the best result in the final examination. That's your future. So you are ruining your future only, not my future, right? You can't ruin my future. You will be ruining your future. So I don't want to tell it over and over, right? Please tell me if you know this, all these things. If you know, I can go to the next lecture and ask whether you all know that also. Otherwise, there's no pointing of explaining things. If you know, those who know things will interrupt and ruin others' life as well. This is what I say, right? This is Sri Lanka, right? You have enough problems, but people look for others' problems. Very sorry to tell you these things for Sri Lankan students. So what I told you is, now
Recording stopped.
Already you have spoiled the lecture, right? I can't start from the beginning. When you interrupt, I can go to the beginning and start it again, right? So I will discontinue from here. I will start a new recording, right? And you will lose the first things, right? So stop recording. I will start recording it again from
Recording in progress.
As a new thing. So I'm not going to explain this. What I told you is world is complex, right? Entities and attributes. Entity is the general term we use to describe anything that exists in the real world. Earlier I told we use the word thing to describe anything in the world. Thing. We are things. Atoms are things. Animals are things, and so on, right? So before the word thing came, we use the word entity. In computing, therefore, we use this whole world entity as well. So entity is the general term used to describe anything that exists in the real world. Exists, right? So entities are basically real things, entities are distinct and independent. So you can't find, two equal entities in the real world. So that is the nature of the world. So therefore, everything in the real world is considered to be an entity. Okay. Attribute. You should know these words. An attribute is a quality or characteristic of an entity. Simply, it is data that describes something. If you take any entity, okay, take any entity. Take an entity called chair. Chair is an entity. Table is an entity. Student is an entity. Okay, atom is an entity. Planet is an entity. You will find attributes regarding that entity. That means the data regarding that entity. Okay, data regarding that entity. Right. What are those? Right. If you take a chair, what data you can see? You can see it's made of wood or iron or steel or wood. That's data. There's a weight for the chair. That's data or attribute. There's a weight. There's a height. You can measure. You call it height of the chair. Okay. Then the color. All these are attributes regarding that entity called chair. Take a student. What are the attributes? Right? The name of the student. If the student is a university or school student, we have an index number or a registration number. Identity card number, national identity card number, date of birth, age, weight, height. All these are attributes of the entity called student. Right? Now let us go to the programming side here. In object-oriented technology, we are learning the technology, right? In object-oriented technology, these entities are called objects. Now you see, now we have three things. I started with things in the real world. Then I came to entity and attribute. Entity and attribute. Now I am talking about object. Okay. Now I am talking about the object. In object-oriented programming, now say in Python. Python is an object-oriented programming language. I explained it earlier. We call an entity an object. We call any entity an object is an object. In object-oriented technology. Object-oriented technology considers everything in real world as an object. Right. Now, in Python's point of view, we consider everything in the real world, right? Everything in the real world is an object, right? It's an object. Now, what things that you get in the real world? Basically, as I told you, you get physical things. Physical things include living things and other physical materialistic things. They are physical things. Other things such as the rainbow, right? They are intangible or imaginary things. You do a transaction. That is a virtual thing. A transaction exists, but it's not physical. It's not physically existing. We call it virtual things. So therefore, if I divide these objects into two categories, we have physical objects and also virtual objects. Is it clear? We have physical objects and the virtual objects. There are two categories. Now look at this diagram. Here you will get physical objects. You can see a bird, house, a child, atomic structure, electrons and the nucleus, a three-wheeler, a tray, pencil here, money, currency note, fruit, iron, a bus, SLTC bus. All these are real world tangible things. Tangible things. They are objects. They are objects. Right? Now, objects will fall into category of imaginary things also. As I told you, you go to the bank, right? You go to the bank, right? And do a transaction there. So you give money, you take money, you deposit money, withdraw money. All these are transactions, right? Transactions. Right. So, but the transaction cannot be touched. Imaginary things. Imaginary things. So I have not put imaginary things in here. I have only put tangible things. But they are objects. So therefore, under our category, objects can be physical things or imaginary things. Imaginary things. Right. Now, in object-oriented technology, what is this term means? What is an object? What is an object? Right? Take a three-wheeler. It's an object, I said. It's a physical thing. It's an object. You will see attributes in there. Attributes. Now take the three-wheeler. You will see there are three wheels, which is number of wheels, 3. You will see it's blue and black color. Then you will see an engine here, etc. All these are attributes or the data regarding the three-wheeler or properties of the three-wheeler. So by these things we judge it's a three-wheeler, because there are 3 wheels and engine is there and all these things. The next one is the behavior. What do you mean by a behavior? Right? Three-wheeler behaves. You can start the three-wheeler, it's a behavior. You can drive it, it's a behavior. Three-wheeler can be driven. Okay? It can be turned to left and right. It can be reversed. All these are behaviors. Okay. There's a unique identity for this one in the world, which is the number plate, registration number. Unique identity. Only this three-wheeler is having a particular identity. Just like human beings, as human beings, we have national identity card number, which is unique. No two people can have the same identity. So that is unique identity. Here it is the vehicle registration number. Right? We have a reference for this one. Reference means where it is now. Right? Number 10 in the parking lot. Three-wheeler is there. So it gives you a reference or a location where this three-wheeler is. So the three-wheeler object has now 1, 2, 3, 4 things. And the type. It belongs to a type also. It's a vehicle type. The type of this three-wheeler is a vehicle. That means you can put the three-wheeler into a class called vehicle class. In the vehicle class, you will have cars. You will have buses. You will have trucks. You will have tractors and many motor vehicles. So three-wheeler is belonging to this class. So therefore, now you should understand that, right? An object has these 5 things: attributes, behaviors, unique identity, reference, and a type. There are 5 things which are related to an object. By now, you should understand that what is an object, right? If you have any questions, stop me, talk to me, ask questions, switch off your microphone and mute your microphone, and again listen. Are there any questions up to now before I go to the next page? Okay, you have any question? Okay, let me go to the next page. Now, what is the connection between real world objects and the computer? Right? Computer is also a real world object anyway. We are using computers in the real world now, so this is also a real world object. Real world object. Right? So, what is the for what we use? For what purpose we are using a computer? Right? For example, if you want to study about 3-wheelers, right? Study where 100 3-wheelers. Say in a park there are say 100 3-wheelers. Right? We take their registration number and store in the computer. Right? We can take the distance traveled by each 3-wheeler during a week, and we store that information, store that data in here. Right? We also can get who are the drivers who drive. All this information can be stored in the computer, and thereby we create, okay, how much they earn. Right? All these things are available once you bring this 3-wheeler into the computer. So therefore, these objects, if we have a way, if we find a way to store these objects, in the computer, then we can manipulate them. If you can bring this rabbit object into the computer, then we can find a lot of information. We can process them. We can see what happens if you give some unknown food to the carrot, unknown food to the rabbit. All these can be predicted. For that, we use the computer. Now, as you know, what is a computer? It's a device which works under the control of software. Software are the programs. Okay, software are the programs. Who write the programs? We write the programs. By using what? We use different languages and we write software. And software allows us to do applications. Do applications. So that we write different applications to suit our needs. And computer is an object again. But this object contains mainly hardware and also software. Hardware and software. Hardware is tangible. You can touch them. Software is intangible again, virtual. Software is virtual, intangible. You can't touch them. Okay. Now we will we will relate these objects. They are different. This is electronic, all electronic. But they are living things. What I have put are mostly living things, and this is not a living thing, this is not a living thing. So living things and non-living things here. They are different. Their behaviors are different. Their appearances are different. Their characteristics will be different from that of a computer. Right. So therefore, to manipulate these things, okay, to do an extensive study on birds. Okay, we have to bring this bird into the computer, but impossible, no? It's a living thing. You can't bring living things inside the computer, right? So therefore, what is the technique that we use, right? We first study this one, get the essential details, get the essential details about the bird, right? Get the essential behaviors of the bird, okay? Combine them together. They are already combined, right? And you bring it as a model. So you cannot bring the bird down here. So what you do is you bring a model of the bird into the computer. So model of the computer is basically virtual, not physical, not physical. And you store the behavior as data. You store the uh, data or the attributes of the birds as data. You can't touch them, right? So therefore, the real world can be brought to the computer world here or the computer through modeling, So that is the technique that we use to connect the real world objects to the computer, right? Once you get the data and behaviors of three-wheelers by modeling this one to the computer, right? We can process them and get very valuable information. For that we use the computer. Is it clear? So therefore, first thing that we see is there are billions of objects existing in the real world, right? These things are physical or imaginary. As it is, they cannot be brought to the computer. What we do is take the essential features and essential behaviors of these things and make a model out of that one and bring it to the computer and store them as virtual objects, virtual or software objects. Now we have two things. In the real world, we have real objects, and in the computer, we have virtual objects that represent the real objects. This baby can be represented by a model in our computer. Physical object. Here it's a virtual or a software object. In the software object, what we need is what's data regarding this child? What behaviors regarding this child? Okay, then the location information. Right? So those are the things that we need actually. What type of object is that one? Those are the things that we need to represent them in the computer. So therefore, this is the most important thing. We represent the real world objects in the computer as software objects. That is the summary. Software objects. Then we manipulate software objects and get all the results that we need regarding real world objects. But real world objects are very complex. But take this tree. It's a very complex entity. But we need only the things that are affected to us, that are effective for us, we need. That's all. So therefore, those are the essential details that we need regarding the trees, not everything. So you take them, get the data, get the behaviors, and make a model and software model and save it in the computer. This is what's happening in object-oriented technology. Okay. Right. Now say, next thing is, take a three-wheeler. It has a unique identity, I said. Unique identity. Get the properties. It's blue color, right? It's blue color and So there's a type, maybe all this data, right? And you represent in here by a software model. That software model is represented in the computer. So therefore, we need some name to represent here in the virtual world. In the real world, we say it's a three-wheeler, but here also we need a name, no? So you give a name, at least three-wheel or something, some name, and represent this model by using that name. Three-wheeler. Here also three-wheeler, but physical. But here the three-wheeler name is virtual. But it represents this this model of the three-wheeler. Okay. Now again, if you get this is a green three-wheeler, no, you get another three-wheeler, right? Year of manufacture is different now. Color is different, driven by different people. They are different, therefore, right? Now, if I bring this one, the green one here, that's different. So, can you give a different name for that? No. You can't give a different name for that. So, therefore, what we use, we again use the same name. We use the same name to represent green one also. So in this case, we say the name that we are going to use in our computer is a variable. At one instant, you are representing the blue three-wheeler. The same thing, same name will represent a green three-wheeler in the next moment. So we use variables to store these software objects in the computer. Software object, variables. Attributes refers to data. Most of the time, they vary. These attributes vary. Just like the color of the three-wheeler, one time it was blue. The next time it was green. Next time it may be red. It varies. So therefore, we use a reference, memory reference. That means a place or an address. We simply call them variables. Python variables is a memory location having a varying references, right? Python variables, because we are going to use the software called Python to handle these real world objects, right? You can use it by another language. You can use another language also to do this. Now I am talking about how you represent objects as variables using Python. Okay, take this example. Consider the attribute color of a three-wheeler. So you can have the name color also. Color of a three-wheeler. It represents this color attribute. Color change from three-wheeler to three-wheeler, red, green, blue, etc. Therefore, we name the memory location as color, right? You name a memory location called color. We can use it to store different reference of colors or three-wheelers. To store different references of color. So the color variable can be red. Color variable can take green. Color variable can take blue at different instances. Therefore, we call this memory location a variable, right? So it keeps a reference of red, green, and blue, right, at different times. We call it a variable. The memory location does not store color directly, but it stores the reference address in the memory, right? So there are, remember, in the lesson number 1 and lesson number 2, I was talking about the history of programming languages. from time to time, we got different programming languages, right? So languages, which uses these old technologies, right? The real world representation is different in the memory. But here we are using modern object-oriented technology, right? It uses a different way. It uses a different thing, right? Now take a memory location, right? So let me show you, how this is done, right? So let me open my board. I think you can see my board here. So let me write few things here for you. Number 1, 56. And they take the real world object now, say three-wheeler. Three-wheeler. Now, one of the attributes is the color. Another may be engine capacity. So these are attributes. Right? We also have behaviors. If I write this way, behaviors, they can be driven. Can be driven, can be turned. So those are behaviors. Because the three-wheeler having these two properties together. Can you see? Together. We call it an object. We call it an object. It is a physical object has also, so you can represent in the computer as, right? Represent three-wheeler as a software object. This is what I was talking about just now. In the computer, you can represent it as a software object. So here in the computer, we have memory. To represent the three-wheeler object in the computer, we have to use memory to store that one, to store this object. So computer's memory consists of memory locations. So these are memory locations. They are memory locations. These are memory locations, okay? Memory locations. So here, a memory location will have reference to address. Address in the memory. Just like our houses will have addresses. They are unique addresses. Right. So to represent this three-wheeler object, right, you come to the memory and catch one of these memory locations. And now we call it three-wheeler. Right. In object-oriented technology, what we do is we don't store the color and the behaviors in here. What we do is we go to another part of the memory. And there we store the value called red or blue. Blue is stored in here. Okay, blue is stored in here. And which is the color. So therefore, in here, I need a name to represent the color in this part of the memory. Now the color is specific now, which is blue. What I do is, right here also memory is the address of the memory. So I have x is the I take this memory value and put it here. So therefore, when I ask color, it will point to the blue. It is pointing to the blue. It is not stored under blue, but this is called a reference. Right? So engine capacity 1500 cc. That is stored somewhere else. So here, again the three-wheeler, right? Three-wheelers capacity, engine capacity. I store it here. I have a memory, y. Take this address and put it here, y, right? And capacity will now points to this 1500, points to 1500, right? So to represent everything, I take color. Color is now pointing to blue, representing, right? Capacity is pointing to 1500, right? Next time when red three-wheeler comes, right? The same color is now, right? The same color, this one, same color will represent red. Same location. So we are not keeping it anywhere. The color now representing blue at one time. It represents red next time, right? The same thing will represent green next time. So therefore, color becomes a variable. We call them reference variables. Because you don't have direct access to blue, but it knows the address of blue here. Reference is known. We call them reference variables. Is it clear? So therefore, in Python or object-oriented programming, we use reference variables. A different kind of variable than the normal variables that we talk in olden languages. Is it clear? Right? This part of the memory we call heap memory. There's no order in here. And here this part we call stack memory. There's an order. There's an order here, but here heap means no order. No order can be seen here. There's no order. Is it clear now up to now what I have explained? What is an object? So therefore, object should have attribute. Attribute means data. We also call it state. Okay. We also call it state, attribute, and behavior. Behavior. How it behaves. Huh? What it can do, what can be done to it, what can be done to it, what it can do, or what can be done to it. Those are behaviors. Now take an animal called dog. Take an animal called dog. What is that? Real world object. Why? Dog has now, right, attributes. Right? It has behaviors. Two things. In the same object. In the same object called dog, we have two things. Attribute is the name of the dog or the color of the dog is a brown dog. Attribute, data, behavior, barking. So they are together, they exist together. Right? You can't find a dog, which is not barking, no? So therefore, brown dogs will bark. Okay, black dogs will bark. White dogs will be bark. Dogs with multicolor will bark. That's a behavior. So therefore, in object-oriented languages, we will see what is an object. Is something that is described by its attributes and behaviors. Attributes and behaviors. So therefore, it's just like object is just like a capsule having attributes or data plus behaviors. So which is an object. Okay, it is an object. Attributes and behaviors. Example is dog. Attribute is brown dog because it's brown in color. Then behavior is barking. You can't separate, no? All brown dogs will bark. All white dogs will bark. You can't separate them. So objects are combination of attributes and behaviors. So they represent the real world. They represent the real world. To bring these real world objects, we use modeling. We use modeling. So let me write that also. Number 2, these are the very essential things that you should know. Otherwise, you will not understand programming. real world, we have objects. Objects will have two things here, right? Attribute plus behaviors combined together, right? So what we do is we take the essential details of this sun, essentials of the real world objects, and we map and model essentials, right? We take essentials and create software model and this software model can be stored in the computer, in our computer. And we do processing. You do processing, further processing on there, in there, and deliver information to the real world human beings. To real world human beings. This is the cycle that we are, okay, this is the cycle that we are using, which is called, say, computing, right? To do this, we use a language to communicate with the computer. So we use here to communicate, we use Python, in our case, Python language to do all these things. It's again software. It's again software. So let me go back to our. Right. Now we know the meaning of real world variables. So once you get real world objects, to manipulate them, we model them, then we use in the memory variables to store. So store them in variables here. Variables, store them and manipulate them. Then only we can process. We can do the process, right? We can do the process after we wrote this one. We use variables here, right? And after that, we do process to get information. You see, now look at this concept, right? In the real world, right, say, these are food items that we eat. Maybe hoppers, maybe rice, maybe cereals, maybe bread, maybe pittu, string hoppers. For all this, we use a bowl, right? Bowl is common. If you want to eat hoppers, you take hoppers and put in here. If you want to eat rice, again you put it here. So therefore, this is a variable. This becomes a variable in the real world. Likewise, once we represent a common name for a category of data, they become already variables. For each item, so we are not, keeping, 6 plates, to eat hoppers, to eat rice. We don't, use, different bowls or plates. We use single thing, wash it and take. So variables work like that. Is it clear? Then there are again things in the in the real world which are not changing. So in the real world, again, we have, look here, I'm talking about real world things. We have objects which are unchanged. Unchanged means everything is changing basically, but they are not changing for a long time, right? Unchanged for a long time. So we call them constants. We call them constants. They are, right? They don't show the varying properties. For example, color of three-wheeler varies. One we see as blue, next one is red, next one is green, next one is brown, and so on. Right? So therefore, we use a variable called color to represent all these things one at a time. But there are things, in the world which don't change much. They don't change for a long time. Everything in the world changes, right? But I'm talking about they don't change for a long time. Things, that are not changing for a long time. We call them constants. So in the memory also, right? In the computer's memory also, you can keep them. Once you store, we don't change it. Once you store, we don't change it. So that is the computing concept. But Python is different. I will tell you later on. Because Python is different and a new language, we don't care much about unchanged objects. Right? So what are these constants? Number one, value of pi. Right? What is the value of pi? Take the diameter of a circle, take the circumference of the, right, this circumference of a circle and diameter, right? Circumference, right, divided by the diameter is a constant. We say it is pi. As I told you, don't use pi is equal to 22/7. Wrong. Don't use pi is equal to 355/113, which is also wrong. Because pi cannot be represented exactly. So what we use is pi is approximately equal to 22/7, which is correct. Pi is approximately equal to 355/103, 113, right? 130. So these are the facts, right? You can't, find the exact value. Nobody has found the exact value of pi. So we are using approximate values. So therefore, don't use equal sign, which is completely wrong, right? It shows your foolishness only, right? So these are constants, right? So even for a very small circle, this is true. Even for a very big circle, it is true, right? This is one category, value of pi. Number two, Avogadro's number. Avogadro's number you have heard in chemistry. It's a constant. All maximum values, are constant. All maximums and minimums. When I say minimum, you have one value. It doesn't change. When you say maximum, today's maximum temperature is 34. right? So nothing, goes above that one. So it's a constant. So all maximum values, all minimum values, Avogadro numbers. So there are Planck constant. So there are many constants that you find in the real world, right? But here in Python takes no interest of giving a lot of preference to these constants. They are just numbers. You can use a name to represent that one. That's all. Or name or reference to use them. Is it clear? Okay. Constants. So here. Then we come to basic buildings of a program. Basic buildings of a program. So let me stop recording and come up in the next video, right? Otherwise, it will be very big. So
Recording in progress.
So this is the second part of our lesson number 5. Okay. Basic building blocks of a Python program. Now I am talking about Python programming. Basic building blocks means so what a program consists of. What a program, okay, is made of. A program is made of these things. Number one is the package, module, variable, functions or method, class, and little bit of constants. So here constants are not given the prominent place, right? In this is the maximum that the Python program can have. You can ignore package. Software developers will use the package names. We are writing small programs, so we don't need to define it as a package, right? We use modules, so modules are there. Variables are there. Functions or methods are there. Classes are there, right? So we have 1, 2, 3, 4 basic items in a Python program, right? In a Python program, we have 4 basic items. Is it clear? Right. Now remember, I told you that when you bring real world objects, they have attributes and behaviors, they cannot be separated, and you represent it as a variable in the Python's memory, in the computer's memory. To represent that in the computer's memory, you need the name, right? You need a name. Name is a word that we use normally. So in programming language, we call it, we give it a different thing. We call it an identifier, right? We call it an identifier. So therefore, what is an identifier? A name given to an element. It's a small error, I didn't say, and okay, a name given to an element in a program. So therefore, what are the elements? Package is an element in my Python program, right? For example, now in the real world also, you see, different people are given different names to identify. So a name of a person is an identifier. So in Python, we use the name identifier directly, right? So how we use this name convention now for us, for human beings, we use the family name and the name. There are 2 parts in the name, okay, or 3 parts, the middle part of the name. Some people have say 10 parts in the name, right? Making themselves big troubles, right? So these are the program elements. If you take a package, right, the name or the identifier or the name given to the package is an identifier, is a program element. Right? The convention that we use is you write in all simple letters. You see, my package. My package, suppose it is the name, we write in all simples. So these are the conventions used by Python programmers. We follow it. Module names. Module names. We use again lowercase, starting with the lowercase character and going towards the name. Sometimes if it is the lengthy one, we can use a separator as an underscore. For example, arithmetic.py. Module names. So modules will have this extension or the type. When you say .py, it says it's a Python module. It's a Python module or a Python file. Okay. Arithmetic is the name. Name.py. Then we have say this is a lengthy name. So I have broken it at the middle saying classic music. Right? So those are the two parts of the name. So you join it by underscore. So names can be, module names can be written this way with the .py. Variable names, again, you use simple letters like say total, okay, maybe name, maybe address, maybe all these are in simples. If you are going for two or more words, we use an underscore. Number list, okay, my salary, okay, my salary, say my weight. In this case, it is separated by underscore. Then the functions or methods that we use in Python, functions or methods. Again, we use the same thing. As far as we can write single functions or methods, we use simple letters. Otherwise, we use underscore to separate them. Okay. Next one is the class names. Class is again right. Again, a building block in the program. Building block. We use cap words. What do you mean by cap words? Cap word means first letter start with a capital. Right. If you are going for second letter, we use start of the next letter as a capital letter. Like big animals, big, no underscore, so we say animals. So that is to designate classes. So we are going to follow these things. Constants, always we use capital. We use capital to represent. So if you want to write max value, you write everything in capital so that you know he has written a constant and say that does not change during the program, but the variables will take different values. Changing means they are taking different values during the running of a program. Okay, right. Right. That is the naming convention. So what is an identifier? A name given to a program element. What are the program elements? These are the program elements. Right? Any Python program will have not all, but major, the essential things are the module, variable, function, and the class. These are optional, you can have constants. Okay. Rules using variable names in Python. Right? We cannot use the names, right, according to our wish. Right, there are rules. Right. Number one rule is, right, okay, rules are specifications to be strictly followed. You have to follow these things. Otherwise, the computer will give you warning messages, error messages if you use different, and it leads to a big misunderstanding among other programmers. So when you write a program, one necessity is You write the program so that you will understand it. Also, others can understand it. That is a must, right? So here there are no rules, big rules, but we call them conventions. Conventions and best practices proposed by experienced programmers. So there's a Python community. There's a Python community who uses this in very effective ways. We follow them, right? One good thing is avoid names that are too general. Too general. Too general means everyone is using, right? Too common, so don't use them, because sometimes the programming languages uses, somebody else will use them. Or wordy. If you use names having many parts, that is also not a good practice. Mainly a good balance, maintain a good balance between the two. So they cannot be lengthy, also they cannot be too general also. So this is a convention that we use generally when you're giving names to program elements. Right? There are rules to follow. First rule is identifier names can have only digits. Okay? Can have only digits 0 to 9. Alphabetic letters. Right? O underscore. Alphabetic means A to Z, capital, simple A to Z. O underscore character. Right? Second is identifier names cannot start with a digit. So digits are allowed, but not at the beginning. That is another rule. Identifier name cannot be a keyword. Right? Keywords are the words reset by the Python. So you will see this is the set of keywords. Right? Now let me go to Python and show you something. Okay, now let us try different, identifier names, right? So they are variable names, maybe method names, maybe function names or class names. Okay. Okay, so let me take a name called A and let A references the data item 10. This is how you write. So once you do this one, the statement is called binding operator or assignment operator. Assignment operator is a very old term. People use them, but good name will be right binding operator. Binding. 10 is bind to A. This is what we say, because we are not storing 10 under A, under the name A, right? We are storing the reference or the address of 10 in the memory under A, not the value. That is the difference in Python, right? Right. Now, once you do this one, it can find A. If I ask A, it will give you 10. Okay. Now look here. Here, my 10 is the normal 10 that I typed. It is data. When I store it and it goes to the Python and comes back, it becomes an object now. See the difference. See the color difference. Why Python is putting that in a different color? Because it's an object now. This is normal number. It's a number, it's an object. Right? Now let us see. Because now A is a name, right? You could store the value 10 with this one. For the reference of this one under A. Right? Now you say S. SLTC. What is S? What is S? it can find now the data item SLTC. Okay. Now let us see. I am going to, so this is the identifier, name of the identifier. So let me try to write this one, right? Okay. Two, okay, two dogs represents, right, two. See, it will show you syntax error. Syntax means wrong grammar. Why? We have a rule, you can't start an identifier with the number, digit. Okay, you can't identify. Now you say, right, without putting two, you say two. Two dogs represented by, this is okay. This is okay. I have joined the two words by using the underscore. It's okay. Now, if I ask what is two dogs, it will give you two. So this is not allowed. This is not allowed. Okay. So let me write another one. Right. If I put here, say, pass is, right, pass is true. Now can you see both are coming as say, or in orange. You will see the orange color is assigned for keywords. What are the keywords? What do you mean by keywords? The words being used by Python itself, right? So if I reserve some certain things so that only I can use, not others can use, right? So such a word is a pass. Pass is a keyword. We call it a keyword. Now you can see what are the keywords in Python very easily, right? You say import keyword, right? I'm importing a module called keyword. Can you see? Keyword simple. .py I don't write here, but it contains .py. Import keyword module, and inside the keyword module, I have a keyword list, KW list. KW list is there, right? I KW, not LW. Keyword list. Okay. Now these are the reserved words in Python. You can't use. So let me see what happened to pass. Pass is here being used, right? Okay. So therefore you can't use false. You can't use none, true. All these you cannot use as the names, right? But you can write my pass, no problem. My pass is equal to true. It's okay. If I ask what is my, it will give you yes, true. That is correct. I have stored the true. True is again a Boolean type. Boolean type. Boolean type means this represents yes, no type of data in the real world. Okay, we call them Boolean or logical data, right? Logical data. Is it clear how to use these names or identifiers in programming, right? Identifiers. You can't use a digit as a starting number, right? But you can use underscore. For example, you can't use special symbols, right? if I want to write I put an underscore, that is okay, my dollar account. This is COUNT. My dollar account has say $100, right? So I want to store that information in the computer. It says wrong. Dollar is wrong. Why you can't use a special character in here, right? Special character in here. Okay. So therefore, special characters cannot be used except the underscore, and spaces are not allowed. Okay. Say you can't write your space name is equal to Bob. Again, syntax error. That means your identifier is wrong. So what you do is you put the underscore here. Now, not a dash. Dashes are also special. Now your name. So now if I ask, what is your name? What is the name that you have stored? It will give you Bob. It will give you Bob. I think you will understand what I am talking about. Right? What I am talking about. Right. Now the next thing. Now you will see, as I told you, num. I am going to store a number as 10. Now here, this is just a name only, identifier. This is the value only. But when I enter, right, and ask what is num, this 10 is now object. Num is the identifier which represent the object, right? Represent the object, right? As I told you, objects have attributes. So 10 is an attribute. 10 is a value, no, it's an attribute, data regarding the number, value, right? So here next time, I can store num is equal to 20 because num is a variable. Now ask number, it gives you 20. Next time it can be minus 15. That's why we call variables. That's why we call them variables. At the same time, as I told you, what happens? 20 is the data part for the value. This is separately kept in the memory. Num is separately kept in the memory. The num will store the address of 20 in its memory under num. So therefore, if I ask what is the identity of num, identity of the object called num represents 20 now. It will give you the address that it is having. So that means at this address, Python has stored the number 20. Is it clear? At this address, Python has stored the number 20. Right. Now let me ask ID of number 10. When I press enter, 10 becomes an object. It will give, if I store 10, it will go to this address. I have not yet stored, but still it's an object. So this object has this address, which is called the identity or the unique number that it is given. Unique number which is given to this. Okay. Let me ask the identity ID of Your name is Bob. Where it has been stored in the memory, I can get it. Different location. So identity of an object is unique. Now we know an object has attributes, object has behaviors, right? So those are the things, which are bonded together. Next thing is an object has an identity or reference in the memory. So this is the memory reference in decimals. You can get it in other number systems. Next I will do number systems, right, for you. Okay, so any object will have a unique identity. This represents where about this variable has stored in the memory. Okay, identity of these things. Also, these variables will have a type. Remember the 5 things that I was talking about? Type. Now say, if I ask type of number 10, it says this number 10 is classified as integers because it's a whole number. Most of you, all of you, then you know about integers, right? Integers. Type 10, right? Take another. If I put 10.5, it gives you another type, which is called float. It says this is classified, an item classified in a different class of items, which we call float. So therefore, for whatever the data item, we have a type here in Python. So all objects are having types, right? So let me check the type of the name. What is the type of your name? That means to what class it belongs to. It says it belongs to not integer, not float, but str class. It belongs to a class called str. Okay, str class. So therefore, for anything we have a type also for an object, right? For an object, object type. Okay. Go back to the lesson. Yeah. Right. Now we know how to write a good identifier. Now let me ask a question. I don't know whether you all are very quiet now, whether you all are sleeping or left the class, right? Don't leave the class. I'm taking attendance at any time. I don't know. I'm keep those in my in a different place, so that will give you a lot of information at the examination, right? Lot of information in the to add border cases to make to give you 2-3 marks for the attendance. Normally we can allocate 10 marks, no problem. So therefore those who come regularly to the class will get that marks, right? I have that information, right? Now let me say, let me write a variable name. Number of years is equal to 2. Okay. Now read it carefully and tell me, give me comments about this one, this statement. Give me comments about this statement. Think and do. Okay, now I am waiting until you comment. Put a chat message. Okay, put a chat message. Don't worry. You will be correct. You will be wrong. If you are wrong, I will tell you. But don't keep quiet. Huh? I'm not going to answer. Things that I'm not answering will appear in the question paper. That's the way, right? And that day you will lose. Okay, come on. You don't have to think much. From the things that we learned here, tell me whether comment on this one. Number of years is 2. What do you say about this? Yeah. Don't waste time. Number of years is 2. You are taking a long time. Are you there? Are you there? I got one answer. Let me see. No. My question you didn't understand. What kind of, what do you see in this statement? Number of years equal to 2. Is it correct? Tell me that one first. Is it correct to use? Okay, tell me, is it a correct variable? So this is a variable name. This is the value now. So I have bound 2 to the variable name here, right? So tell me whether it is correct or not. Again try. Don't become, dependent people. Don't wait until, I answer, right? You have to try. Otherwise, you will never learn. Let me try. This is correct. Okay, good. What about others? Others comments? How they may 117 Kuta Hari correct kiwa then Hari Tavadina correct the wrong. Yeah, what about others? I'm getting series of correct things. Yes. Technically, this is correct. Number of years 2. Now look here. If I write a variable, say num is say 10. Say num is 2. Okay. Next time I say number is equal to 3. The same name. Now it is referring to 3 because it's a variable, right? Number is equal to 5. Now it is referring to 5. Number is equal to 10. Now it is referring to 10, last value. Got it? But I'm asking here, number of years, it appears to be a variable and we are doing the same thing. Number of years is equal to 2. Right? If I ask what is number of years is years, if I ask, it will give you 2. This is technically correct. Okay, this is the name of a variable we have written in according to our according to our rules. So it is correct and it is giving the result also. But what's wrong with this one? What's wrong with this one? What's wrong with this one? Take this one and write. Okay. Add 1 to the variable. This is how you write. Take the previous value, which is 2. Add 1 to the previous value, which is 3. Again store. Equal means again store in the same variable. So now it says, okay, after this one, if I check, which is 3. Now what do you say about this one? Number of years. Yes, therefore, he say human beings basically and animals, living beings, no, right? එතකොට මේක
Recording stopped.